The heating and change of state both together. Now is the time to compare and elaborate both together. One by one, we have gone through the change of state and the process of heating or cooling. You take one substance in its lower temperature stage, obviously it will in solid state and start heating. You start heating solid, then its temperature will gradually rise and it will ultimately reach melting point. There, temperature will stop increasing. This side is temperature. When the process of melting takes place, temperature remains constant, and after a limit of time, it is completely melted. Now you get liquid. Liquid will start heating. Ultimately, boiling point will be reached over there. That's T2 here. Then at boiling point, temperature won't increase, it will remain constant and boiling will take place. That is the change of state. When it has completely liquefied, it has totally been vaporized, then in that case you are going to get the gas. Gas will again be heated till its temperature goes on increasing. So, solid, liquid and gas, three stages in heating processes you notice, and when there is change of state, it is A to B, that is solid to liquid, it is C to D, that is liquid to gas. Now here we are using the heater that is having the constant power, then in that case the heat supplied will be given by power into time interval. Suppose the time interval used here is delta T, and you also know Q is equal to mc delta T. This is the temperature interval. Now, if you take the ratio C delta T by capital delta T, this is going to be here mc upon P. Or you could say C equal to delta T upon capital delta T. It has been reversed. So, in order to correct it, we are going to write it like C equal to P into P upon M into, you see, this is 1 upon tan theta, because if you take this angle as theta, tan theta is going to be delta T upon small delta T. And you notice the inverse of this thing, so it becomes 1 upon tan theta. Tan theta would be known as slope. So, a specific heat here is directly proportional to 1 upon tan theta. You could say this is inversely proportional to slope of this temperature time graph. This is temperature time graph, but the heater or the source of heat that we have preferred here is having constant power. This relation we obtain. Then what is calorimetry? Thermometry we have been studying so far, but now calorimetry. Calorimetry means whenever the two bodies are brought in contact and they are at different temperature, there will be heat transfer. Higher temperature, from higher to lower temperature, the heat will flow and ultimately it will be equal for both. So, hot body will liberate or supply the heat, cold body, colder body will receive the heat. This is the principle of calorimetry. You could say it is based on principle of conservation of energy, because it says that heat given is equal to heat taken. Ultimately, there is no loss of energy. Suppose there is a cold body and hot body, MH, CH and TH. This is hot body, MC, CC and TC. Liquid, mass, specific heat, temperature. Liquid, cold, mass, specific heat and temperature. Hot temperature will reduce, cold temperature will increase, and suppose the mixture has the temperature Tn. So, heat will be given by the hot body, that is MHCH TH minus TM, and here heat will be absorbed by cold body, MCCC Tm minus Tc. By solving this equation and isolate this T mixture, you are going to get this relation. This is MH TH plus MC TC upon mass of the both of the liquid, that is the total mass. This becomes the formula for temperature of the mixture.